We will now move to the intermediate value theorem. So let us look at the statement. Suppose that f is continuous on the closed interval a to b, and let n be any number between f of a and f of b, where f of a is different from f of b, then there exists a number c in the open interval a to b such that f of c equals to n. So let's look at these graphs and see how this definition or the statement applies. So we can see that f of x, it's continuous. I never have to remove my pen in order to draw f of x. Let's look at the second graph. It's continuous as well. So then we would like to have an interval a to b. So this is our a and this is our b, and in the second graph we have as well a and b. And we have f of a and f of b, which are different from each other. And then we have n. N is between f of a and f of b. So notice how there exists this point c right here, such that f of c is equal to n. So again, in the second graph, we have more than one point c. So f of c1 is equal to n, f of c2 is equal to n, and f of c3 is equal to n. Let us apply this intermediate value theorem to this example. Show that there is a solution of the equation 4x cubed minus 6x squared plus 3x minus 2 equals to 0 between 1 and 2. So it's really good how they gave us the interval. So we are looking for a solution between 1 and 2. This means a is equal to 1, b is equal to 2, and our solution is 0, so our solution gives 0 in the equation, so n is equal to 0. Now let's try to find f of 1. This is equal to 4 times 1 cubed minus 6 times 1 squared plus 3 times 1 minus 2, which is equal to negative 1. Let's find f of 2. This is 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2, which is 12. Notice how f of 1 is less than 0 and f of 2 is greater than 0. So let's write this down. F of 1 is less than 0, less than f of 2. And we will let n equals to 0. And we already mentioned that n equals to 0, so we will say that n equals to 0 is a number between f of 1 and f of 2 as we wrote the inequality above. And in order to apply the intermediate value theorem, the function f has to be continuous. So the function f is a polynomial, so it is continuous on all real numbers, so it is continuous on the closed interval 1 till 2. Then, because of that, we can now apply IVT. So IVT states that there exists a number c between 1 and 2 such that f of c is equal to 0. So the equation has at least one solution c in the open interval 1 till 2. So we can write this down as 4c cubed minus 6c squared plus 3c minus 2 equals to 0. So now we will move to another example where the interval is not given. So we would like to show that 2x cubed minus 6x plus 1 equals to 0 has one solution. Of course, we can always set f of x to be equal to this 2x cubed minus 6x plus 1. So we want to choose the interval. How do we do that? We can just try numbers, just literally by trial and error. So what happens if I plug in 1? If I plug in 1, I get negative 3. Now what happens if I plug in 3? I get 37. And of course, you can keep on trying other and other numbers. There is not one correct interval. The only condition in order to allow you to solve this easily is that the first one should be a negative number and the second one should give you a positive number. So what you do after that, you find after finding f of 1 and f of 3, you notice that f of 1 is less than 0 and less than f of 3. So we would like, since our answer we want it to be 0, so we would like n to be 0. So n is a number between f of 1 and f of 3. And notice also that f of 1 and f of 3 are not the same. They are not equal, they are different. And this is one of the conditions in order to apply IVT. So the function f is a polynomial, therefore it is continuous on all real numbers and therefore continuous on this closed interval 1 till 3. So by the intermediate value theorem, there exists a number c in, notice how this is an open interval 1 till 3, such that f of c equals to 0, and then we can plug in c, we get 2c cubed minus 6c plus 1 equals to 0, and therefore this equation has at least one solution.